Hi, I'm Elise Bonnail from Télécom Paris, and I will present our paper called Was it real or virtual? Confirming the occurrence and explaining causes of memory source confusion between reality and virtual reality. Have you ever found yourself unsure whether one of your memories comes from your imagination, from a picture, or from reality? This common experience is called source confusion, when memories are attributed to the wrong source. An example of source confusion is when you vividly remember someone telling you a story, but you later realize it was actually something you read in a book or saw in a movie. Source confusion can result in minor inconveniences, like repeating a joke to the person who originally shared it with you. But it can also lead to the creation of false memories and have more significant negative consequences. Confusing something heard in the street with something read in a newspaper can lead to the spread of misinformation or even to false eyewitness testimonies. More generally, memory errors and the way we remember the past has important impacts on our lives, because our memories shape our self-perception, our social interactions, and our future choices and behaviors. Source confusion, and specifically the confusion between imagination, pictures, and reality, has been studied by cognitive psychology researchers to understand how, when, and why it occurs. For example, in 2002, Wen et al. Showed that exposing people to manipulated pictures of them in a hot air balloon can lead to the creation of a false memory of that event. But today, new immersive media like virtual reality are emerging. VR is a new source of experience that could also be confused with reality. You could experience something in VR, like taking a hot air balloon ride above Paris, and later think that it was real. But source confusion between reality and VR, which we will call VR source confusion, has been very little studied until now. Given the rapid development and adoption of this media, and knowing the consequences of false memories, it becomes important to understand the occurrence of VR source confusion and to understand its causes. In the source monitoring framework, Johnson et al. Explained that memories are not always labeled with their sources. Identifying the source of a memory is a decision process done when remembering the event based on the characteristics of this memory. They identified that memories from real sources tend to have more sensory characteristics, like auditory information, more semantic content, like meaningful information or details, and more contextual information, like spatial or temporal details, than memories from imagined events, which helps you to distinguish reality from imagination. Johnson et al. Note that this decision process takes into account other factors, such as prior knowledge and assumptions. An event that is judged as highly improbable, such as the memory of a flying whale, is more likely to be identified as imagined, regardless of the amount of sensory and semantic details of this memory. The source monitoring framework is a general framework that helps to understand how people identify the source of their memories. It can theoretically be applied to all kinds of sources, but there is currently a lack of understanding about how this framework applies to the specific case of VR versus reality source identification. A characteristic of VR is its capacity to elicit a sense of presence, the feeling of being there. There is currently no understanding of how these specific aspects of VR might influence VR source confusion. One of the remaining questions is, could presence have an impact on VR source confusion? If you have the feeling of being there when you are experiencing an event, are there more chances to later remember this as a real event? And more generally, what are the causes of VR source confusion? In this paper, we present a lab study that we adapted from a study initially conducted by Hoffman et al. In 2001. We updated it to recent technology using an Oculus Quest 2, and we integrated additional questionnaires to explore which characteristics of VR might influence VR source confusion, and whether the sense of presence could impact this phenomenon. I will present the study design quickly, but I invite you to read the paper for more details. During this study, participants entered the room and were asked to put a VR HMD where they would see the virtual room modeled after the real one. So on the left you see the real room, and on the right the virtual one. Then they were asked to play with a virtual tennis ball to let the participants spend some time in the virtual environment and eventually build a sense of presence. Then they were asked to observe a virtual object that appeared on the box. So for example, a virtual apple. After this task, they answered a questionnaire to assess their level of presence. Participants repeated this task 20 times, 10 times in VR and 10 times in reality. So the real task was structured in the same way as the virtual one. First, the participant was playing with a real tennis ball. Then the facilitator put a real object on a box, for example, a pair of scissors. And then the participant was asked to observe it. And then they answered a similar questionnaire about their experience in reality. So overall, each participant observed 10 objects in VR and 10 objects in reality in a random order. You can see there the real objects that were used and their equivalent in virtual reality. Then, 1 and 2 weeks after the study, participants completed the source identification test. They were asked for each object to identify if they saw it in reality, in VR, or if they do not remember seeing this object at all. The results confirm that VR source confusion occurs. 20% of the objects that were presented in VR were later identified as real, which is twice more than one of Bonnail observed in 2001. So you can see on the figure on the left the results obtained in 2001. So you can see the percentage of virtual objects that were identified as virtual, as real, and that were forgotten. And on the right, you have the results of our study. So again, the percentage of virtual objects identified as virtual, as real, and that were forgotten. So this increase in source confusion suggests that the technological progress made over the last 20 years might increase the frequency of VR source confusion. From our quantitative analysis, we did not find a correlation between the measures of presence that were done during the study and the source identification results. So we did not find an impact of the sense of presence on source confusion. The most interesting part of this study was the qualitative data. 2 weeks after the study, after completing the second source identification test, participants were asked to explain the reasoning behind their answers. If someone identified the apple as real, they were asked to explain why they thought that this apple was real. The qualitative data gave a lot of information about what happens in the mind of participants when they have to distinguish if a memory comes from a real or a virtual experience, which helps to understand why VR source confusion occurs. When participants were asked to identify the source of an object, they first retrieved some cues from their memories. For example, they remembered noticing the way the light was reflected on the apple or the shadow it casted. Then they compared these cues with their prior knowledge and their assumptions about reality and about VR. For example, a poor reflexivity and a lack of shadows was associated with the assumption of what VR looks like. And on the contrary, a memory of a high reflexivity was associated with reality. Then they made a source identification decision based on which assumptions the cues match. So if they remembered noticing that the apple wasn't casting any shadows, they would identify it as virtual. From a qualitative analysis, we identified the cues that were used. For example, sensory feedback was another type of cues. The absence of smell of fruit was associated with VR, and the presence of sounds was associated with reality. Functional properties is another example of cues we identified. If a participant remembered the absence of a functional detail of the object, for example, the absence of electronics inside the USB key, they associated it with VR. On the other hand, the presence of a functional properties or trace of use of an object was associated with reality. You can find all the cues and assumptions that we identified in the paper. Consistently with the source monitoring framework, we found that VR source confusion occurs either when cues are incorrect, for example, if you remember that the apple did not cast a shadow but it actually was the case, when cues are missing, when cues are not specific to one source. For example, you remember that the banana had a smooth skin, but this is neither specific to reality nor to VR. Or when you hold incorrect assumptions about reality or about VR technology capabilities. For example, if you incorrectly assume that textures in VR cannot be detailed. Identifying the causes of VR source confusion is a first step toward designing protection mechanisms to limit this phenomenon. So from these insights, we joined the discussion that was started by Slater and al. About the ethics of realism. The idea of a VR technology so advanced that it is indistinguishable from reality itself captivates imaginations, but it remains a huge technological challenge. However, the results of our study confirm that VR can already be confused with reality, despite the limitation of current technology in terms of realism. The confusion does not occur during the experience, but when thinking back to the experience. So we should not wait to reach the perfectly realistic display to start addressing the ethical, psychological, and societal implications of confusion between virtual and real experiences. So we encourage future research to explore further the causes of VR source confusion in order to develop protection mechanisms to limit VR source confusion in contexts sensitive to memory errors. I hope you enjoyed this presentation and thank you for watching.